Select the major product of the following reaction. So if we look at our starting material, we see that this is a ketone. And if we look at what we're reacting it with, you need to recognize this reagent. So let me redraw it. So you've got a CH with a double bond to the phosphorus, and pH3, that is 3 benzene rings. And so we can also draw a resonance structure of this, where we can show this actually as a carbanion, so moving this, and a positively charged phosphorus. Whoops, that should be an H3. So let's just get rid of that quickly. I got excited and almost drew an extra phosphorus, but it's not, it's 3 benzene rings. Okay, so we've got this reagent, and what this is something that's known as an ylide. All right, and so this is a reagent for a Wittig reaction. So you hopefully recognize that this is a Wittig reaction. So notice, although it is spelt with a W, we pronounce it with a V, Wittig. Okay. All right, and so what this is going to do is it's going to add to your ketone. So let me just go ahead and redraw this. So here's the ketone, right? And this shouldn't surprise us. This looks like a nucleophile. We know that ketone carbonyls are electrophilic, so I'm going to line them up so that they can react. So I'm going to put my anionic carbon pretty close to that, recognizing that it also has a positive charge to phosphorus. And I am lining this up specifically because I'm going to have a reaction between the phosphorus and the oxygen, so I'm putting them next to each other. And then that phosphorus still has 3 phenyl groups, and we still have 2 carbon atoms off of that CH. So let's make sure that we have drawn those. Okay. And so what we're going to see here is really interesting. We're used to seeing nucleophiles attack carbonyls, and it's definitely going to happen. So we're going to have this nucleophile attack the carbonyl, but as it does so, this pi bond is going to swing towards the phosphorus. So phosphorus-oxygen bonds are pretty strong bonds, so that's going to be a driving force here. So this is a cycloaddition, so we're actually forming a 4-membered ring here. So it's probably going to look a little bit funny because we're going to have a 4-membered ring fused to our 5-membered ring. So there's the initial 5-membered ring. There is the carbon oxygen. And so we want to recognize is that this oxygen is now bound to the phosphorus. It's still got its lone pairs of electrons. And this phosphorus was bound to this CH. So there it is. And that CH is now bound to what used to be our carbonyl carbon, and we have CH2, CH3 as well. So the R group, the whole thing has come along, right? There's no reason for it to fall off. But from here then, this probably looks pretty strained, and it is, and it's going to collapse. And the driving force for this collapsing is forming a phosphorus-oxygen double bond. So I like to draw my arrow first to form the phosphorus-oxygen double bond. And this is reactions are basically going in, your electrons are basically going in a circle, so it actually does not matter which direction you draw your arrows, as long as you are forming a phosphorus-oxygen double bond and a carbon-carbon double bond, because that's going to be the products. So let's draw those products. So what used to be our carbonyl carbon, that oxygen is now gone. It's gone and rendezvoused with that phosphorus. And so we're forming a carbon-carbon double bond. So that's at CH, and it still has the CH2, CH3. And so we formed that. And we have also formed this triphenylphosphine oxide. Okay, and this is a byproduct. So what the Wittig reaction is, it's a really good way to take a carbonyl. So this reaction is a way to take an aldehyde or a ketone and form an alkene with a really high degree of control over the regiochemistry, actually complete control of the regiochemistry. Your alkene is going to be between the anionic carbon of your ylide and your carbonyl carbon of your aldehyde or ketone, no question. So really good control, really typically high yielding reactions and actually quite easy to work with. If you're looking for the fast way to draw the product, here's what you might want to recognize, is what you're essentially doing is that this carbon atom and this carbon atom are going to form your alkene. So you're basically just putting a double bond between those. So that is where your alkene is coming in. And if we want to check and see where this is on our options, it is C here, where we've got this. We had 1, 2, 3 carbon atoms of our ylide, and they've added here 1, 2, 3. So that's what we're saying. This carbon 1 is going to snap into where the carbonyl carbon was with a double bond.